So A and B are the endpoints of load line. If you join A and D, that is A and B, that is going to be called as your DC load line. And Q point will be exactly in the middle of your DC load line. Assume, see here, A value is 3 milliamperes and B value is 24 volt. 3 by 2, 1.5. 24 by 2, 12. So if you draw a line from 1.5 milliamperes horizontally and 12 volt vertically, you will be meeting exactly at the Q point. So if you want your BJT to work as a common emitter amplifier, your current to the device should be 1.5 milliamps and VCE should be equal to 12 volt. It should be half of VCC and IC, maximum IC. Okay, so AB is your DC load line. It is called as DC load line because it is this line is got by applying DC voltage. And ends of the DC load line represent saturation and cutoff condition. The midpoint of your DC load line will refer to the quiescent point or the operating point of your transistor. And what is the value of the quiescent point? The current will be half of the maximum current. The voltage will be half of the maximum applied voltage. Okay, so these important properties of Q point you should understand from this graph. And what we have seen here, this line AB is called as DC load line. So if I say DC load line, then you will have a doubt. Is there something called as AC load line? Yes, AC load line is also there. We will read about the AC load line sometime later. Okay, so thus this line AB is called as DC load line. So once we know the two endpoints of the DC load line, we can draw the DC load line. And as I told, the Q point is located exactly at the midpoint of AB. Midpoint means, you will be dividing the maximum value by 2. That's why I said it is the maximum collector current divided by 2 and the maximum applied voltage divided by 2. And I can say this Q point is going to lie exactly between the two regions, saturation and cutoff. So Q is going to be exactly between A and B. So if Q is exactly in the midpoint, active region. If Q is going to move towards A, it is going to be saturation. If Q is going to move towards B, it is going to be cutoff. So this straight line will connect all the three regions of your transistor. So our focus will be retaining this operating point exactly in the middle of your DC load line. So for that only, we are going to design this biasing circuit. Okay. In order, why we say that Q point has to be exactly in the middle? Why can't it be slightly up or slightly down? The reason is, if the Q point is slightly exactly in the middle, whatever input you give, it will be faithfully reproduced. If you give a sine wave for amplification, that sine wave will be amplified and got perfectly. You get an amplified version of sine wave when the Q point is exactly in the middle. When the Q point is slightly moving up or slightly moving down, your sine wave will look like this. Your sine wave will look like this. Some part of sine wave will move up. Some part of sine wave will move down. Sometimes the sine wave will be clipped off. Can you see the difference? This portion has to be rounded off, right? But this portion is clipped off because the Q point is close to cutoff. If the Q point is close to saturation, the sine wave will be starting moving up or down. But if the Q point is close to cutoff, some portion of sine wave will be cut off after amplification. So that is why we say that the Q point has to be exactly in the active region or exactly in the midpoint of the DC load line of your amplifier. So before you want to buy an amplifier, first in industry what they will do, they will first discuss what transistor they are going to use, and they will first fix the operating point. How to fix the operating point? By designing the values of VCC, RC, RB. So once the biasing circuit is ready, they will test your amplifier with the sine wave signal to see if the sine wave is perfectly amplified. Only if the sine wave is perfectly amplified, the Q point, everything is perfectly set, they will finalize the circuit design. Otherwise, they will keep on changing the values of all the parameters to ensure that the Q point is exactly in the middle of your DC load line. So just like that, designing the circuit you cannot send the circuit for production, right? You have to do a lot of testing because these transistors, these semiconductor devices, they are highly temperature dependent, right? So any small change in parameters will affect the circuit performance heavily. So you cannot take risk in semiconductor. So before a circuit comes as a final product, lot of revisions will go in, lot of testing will be undergone to ensure that the device will work for all possible conditions.